Okay, everybody, welcome back. And let's try something here that we'll see how it goes. All right, so here's what we have to do next. There's some mathematics with pH, and what we're trying to do is figure out how many of these hydrogens are floating around in our solution. Okay, and by the way, this P in pH stands for power. Okay, stands for power. So we're trying to figure out how powerful or how many hydrogens are floating around in our solution. Okay, so we have a scale. And on a scale, pH scale, it goes from 0 to 4. It goes from 0 to 14. And I'm on the pH part of this scale. 0 through 7. This area of the scale, we say it is acidic. Okay, so that is acidic. The closer you get towards the other side of the scale, the weaker the acid. So 7 is actually, I'm going to just color this yellow. 7 is neutral. All right, 7 is neutral. And 6 is a weak acid, 5, 4, 3, 2, 1. And then we get down here to this area. This area here is strong. Okay, this is a very strong acids. 0, 1, 2. These are strong acids. 6 is a weak acid. Okay, so as we go past neutral and on the pH scale and get to the other side, all right, so we're going to say this side over here is basic or alkaline. All right, so we're just going to use basic. And a strong basic is 14, 13, 12, 13, 11, 12, 13, 14. You're starting to be a strong base. And on this end, 8, 9, and 10 is a weak base. So on a pH scale, 0 to 6 is your acids. Your strong acids are going to be towards 0 and 1. And on the base, if your pH is like 12.5, it's in the strong base area of the pH scale. Okay, you may not have known this, but there's also a pOH scale, and it's the flip-flop. Okay, so it's the flip-flop of the pH scale, and this is the power. We're trying to figure out how many OHs are in our solution. And here's the OH, your negative charged. How many of those are floating around in our solution? Now, as you can see, since everything's flip-flopped, this is going to be on a pOH. Don't get confused here. On a pOH scale, here we go. This is our base. All right, and so if it's acidic, it's going to be on this end of the pOH scale. So again, it's flip-flop. So if something's going to be strong on the pOH scale, if it's strong acidic, it's going to be down here around 13 and 14. It's going to be, acids will be weak if we're on the pOH scale. Remember which scale we're talking about. On the flip-flop, on the basic side, again, we're going to be strong. Everything's flip-flop. If it's a strong base on the pOH, it's going to be around 1 and 0, 2, 1, 0. It's strong. Again, this is the weak. And, of course, 7 is neutral. Okay, so that's it. I wanted to clear this up. There's two scales. There's a pH and a pOH scale. They flip-flop each other. And so, and 7 is neutral. Alrighty, so now you must understand this first. Just understand the pH scale. Basically, we'll be looking more at the pH scale. We'll be looking at both of these scales. Just remember where the strong and the weaks are. The pOH, the flip-flop, base and acids. A strong base is 0, 1, 2. And a strong acid is 14, 13, 12. On the contrary, on the flip-flop of the pH scale, measuring the H's, A strong acid is 0, 1, 2. And a strong base is 12, 13, and 14. So just remember that. And you may need to draw this down if you want to. But it's going to be on the matter. Well, take that back. It's going to be on the notes that I'm going to send you. So this will be on the notes. Okay, in your notes, here's what we have. Here's all the formulas up here. They're just up there. Let me go through them quickly. This is really easy. So don't. There's no need to have any anxiety over this. Over here is the again is our scale. There's our pH scale and our pOH scale. And notice they're flip flop. Okay, so here's our question. We're going to calculate the OH, the H, and or the H. Okay, we're going to calculate the H's and the OH's. All right, so that's it. So we're calculating the pOH, the pH, the H, and the OH. All right. It tells us what the OH already is. Okay, so it tells us we have this many. Concentration tells us how strong our solution is, how much of this stuff is in there, and we have 4 times 10 to the negative 3 molarity. So this is how many OHs we have. Okay, so our question is, let me go back and just clean that up. Again, making these videos, I'm not going to go back and remake them over something I say that's not clear. So just let's clear it up. So we're going to calculate the pOH, the pH, and then how many of these hydrogens are floating around in our solution. All right. So here we go. So it tells us, well, it gives us a hint. We have to have some kind of a hint to figure this out. So it's going to tell us how many OHs we have. All right. So since we know how many OHs we have, we can now calculate the pOH. All right. 4 times 10 to the negative 3 is how many OHs we have. And the pOH is going to be, if we go back up to our scale up here, it's going to be 0 through 14. That's our pOH. So we got to figure out what our pOH is. Okay, and so here's how we do it. All right, so our problem tells us we're going to figure out the pOH. So we're figuring out this P, the power. It's going to be 0 through 14. And it gives us our OH, 4 times 10 to the negative 3. All right, so here's our formula. Our formula is negative log, in brackets, 4 times 10 to the 3. So over here, I'll put the pOH is negative log 4 times 10 to the negative 3. So that's our pOH. All right. So here are the calculator keystrokes. Again, I'm using the calculator in the classroom with this. And since you're probably going to use the calculator on your phone, you have to go to the part of your phone that has log. All right. And it's real simple. You're going to go negative log first, push negative log. All right. After you get negative log, all right, then you're going to put, well, negative log 4 times, you're going to do 4 times 10 to the negative 3. So it's negative log, click parentheses, 4, and then you're going to shift log because you got to put negative, well, basically, this isn't going to work. All right. Here, you got to figure this out on your calculator. Basically, you're going to do negative log, all right? And then you're going to put the negative log of 4 times 10 to the negative 3. That's what you're doing. Negative log and 4 times 10 to the negative 3. So basically, you're going to get negative log on your calculator. In parentheses, 4 times 10 to the negative 3. So that's what we're doing here. In parentheses, you're putting 4 times 10 to the negative 3 in parentheses, and your answer should be 2.4. So this is your answer, is now a 2.4. And that's what we want because we're looking for a P, a power, and it's 2.4. And if you go back and look at our scale, our pOH, remember it's a flip-flop, it's going to be right in this area, so it's a strong base. So let me just go back up here. So if you see up here, 2.4 is going to be in this area here, so it is basic. So pOH, here we go, is going to be basic. All right. Our pOH is 2.4. And here we go. So our next problem, our problem here, we got to figure out now what our pH is. And here's what's great about pOH and pH. Here's our formula up here. pH plus pOH, always together, they equal 14. Simple. All right, since we know our pOH is 2.4, then what's our pH? So here we go. Our pH is going to be 14 minus 2.4. Remember, our pOH is 2.4, so this is our pOH here. 14 minus 2.4 equal 11.6. So this means our pH is 11.6, meaning if we're using the pH scale, it is also basic. So let's go back up here. Here's our pH scale on the bottom, and it says it's 11.6. And we see 11.6 is up here, and it's in the basic area of the pH scale. So this is confirming that in our solution, it's a basic solution. So we know our pOH is 2.4. Our pH is 11.6. 11.6 and 2.4 equal 14. All right. So we got that figured out. So we got our pOH figured out, and we have our pH figured out. So all we're left now is to figure out these hydroniums, these H pluses, how many of them are floating around in the solution. Okay, so here's the formula for it. So we're trying to figure out the H plus. All right, so oh my goodness. I'm touching my eyes. Don't touch your eyes anymore. Wash your hands, touch your eyes before you touch your face. Okay, let's find out. Here it is. Here's a formula to figure out our H plus by itself or the OH. This is concentration now. This is not the pH. Keep this in mind. This is how many of these characters are in our solution. It's not the power. It's how many of these characters are floating around. And so it's really simple. Here's the formula. It's 10 to the minus pH of that character we're trying to find. And since we're trying to find the H, let's go back to our notes. Here we go. So this is what we're looking at. It's negative minus pH. Okay, so we got to find the pH first and get its negative. And we see our pH here is 11.6. So we're going to take our pH, which is 11.6, and we're going to add it into our formula here. So we're going to put it up top. So it's going to be 10, and our power is going to be negative 11.6. Remember, we're looking for our power here. Power of our H's equal 11.6. Now we're going to put that power with the 10, but we're going to make it a negative. All right, so it's 10 to the negative 11.6. Just get your calculator. This is a shift log. Negative 11.6 equal. You just got to go to your calculator and do this. So basically, it's 10 to the negative 11.6. And you should get 2.5 times 10 to the negative 12. All righty, so that's it. So that gives us... So that's going to give us 2.5 times 10 to the negative 12. Okay, so our hydronium ions, again, H3O is a nickname for H plus. These two characters are the same. They're just nicknames. So H plus is H3O. They're the same, and so it's 2.5 times 10 to the negative 12 molarity. So let's sum all of this up. We figured out our pOH by doing all of this, and we found out our pOH is 2.4, which is basic on the OH scale. Since we now have our pOH, which is 2.4, we now can figure out our pH because it's the difference. They both equal 14. So our pH is 14 minus 2.4, which gives us